In today's presentations, we'll explore the various type of variables used in multivariate addition making analysis. I am Dr. Parthasarathi Mishra, Associate Professor at the Faculty of Architecture, Sri Sri University. Let's dive into this crucial point that forms the foundation of effective decision making process. In the last video, I have discussed about the different types of MCDM method that we are going to discuss in individual videos. However, in this particular video, I am going to discuss about the types of variables that can be used in the multivariate decision making analysis. So, this is the content or today's presentations. We'll cover six main parts. First, introductions, then qualitative variables, quantitative variables, mixed variables, their advantages, disadvantages, how we can use them in the multi-criteria decision making analysis, along with handling and processing the different variables, along with some of the practical implications. So next, begin with the introductions to multivariate decision making analysis or MCDM and understand why variable types are crucial in this particular field what we are discussing in this particular presentations. Next is the overview of multivariate decision making analysis or MCDM. Now the definition and importance. Multi-criteria decision-making analysis involves evaluating multiple conflicting criteria along with multiple alternatives in the decision-making process. It is essential because it helps in making well-informed decisions by systematically comparing alternatives. So we have one-to-one comparison among the variables. At the end, we'll get the index value for the different alternatives so that it will be very easy for us to choose which kind of alternative is the best solution, optimum solution, worst solutions. Uh, Next is the application in various fields. MCDM is widely used in the fields such as engineering, healthcare, business. It assists in resource allocations, project selections, and strategic planning by providing structured analysis. As an architect, I can say, as a heritage specialist, also I can say, this MCDM processes can be used in uh, identifying, selecting, uh, for the best heritage among a group of heritage, or I can say what kind of different alternative use that can be possible. Suppose there is a fort, so in that fort what kind of different use or the current use, because previous use is not there, so what will be the best preferable use that can be used uh, for the survival or the best possible way. So now, these are the essential concepts of multi-criteria decision-making analysis. One of the major step is to identify the criteria and the alternatives. Criteria are the parameters or attribute from which we are going to uh, evaluate the alternatives, and alternatives are the our for which we are going to make some kind of decisions. For example, to buy a car, fuel efficiency, then cost, then horsepower, all these are criteria, whereas the alternatives are like different types of vehicles that we are going to evaluate, and from that which is the best optimum solutions that we can get, that we have to choose and we are going to buy it. Now second step for the MCDM is the decision matrix. It is a tool for comparing alternatives against defined criteria. So for each criteria we can choose among two alternatives that this is the uh, better or this is the worst alternatives. But when we have a multiple number of criteria involved in the decision making process, then it will be very difficult or very complex in nature for evaluating the alternatives. That's why I can say alternatives with multiple criteria is always a difficult thing. Again, there is a another important point that involves is like the whether the parameters are beneficial or the non-beneficial criteria. For example, I can give you an example of water. In water, we have different types of parameters. I am just giving two examples. One is the water purification level and water pollution level. In water purification level, if the purification level is high, then we can say it is beneficial for us. Whereas water pollution level, if the values are high, then we can say it is not beneficial for us. For that's why water purification level is a beneficial criteria, whereas water pollution level is a non-benefit criteria. And some of the studies, it is also so the cost benefit criteria. Cost means which is negative for the alternatives while buying or selecting, whereas the benefit are the parameters with increased value, it is beneficial for us, then we can say it's a beneficial criteria, and other than that those are non-beneficial criteria. Another point is like weighting schemes. Like we have two particular parameters for evaluating a particular alternatives, then we have two parameters. Now the question is which parameter is more important than the other parameters. That's why this weighing concept is comes into the picture. So weighing is something like whether, for example, we have a school, matriculation level school. In that school, we have different subjects like physics, chemistry, mathematics. Now the question is which particular subject is more important, whether it is physics, chemistry, or for biology or mathematics. So whichever subject is more important for the students for their career, that subject they are going to give more importance rather than the other subjects. That's why, whereas the carrying marks are same. Now the question is which particular subjects they are going to focus. For them, they are giving more importance for their career opportunity. Here, our alternative is which career, which kind of subjects is demanding. For that, that kind of subject is giving, students are giving more importance. That's why the level of importance upon one parameter to another is one of the concept of MCDM. So let's see. Next is like objective of the analysis. One of the is importance of the variable type. Now we have different types of variables. Which type of variable is essential for our evaluation purpose, that we have to see. Understanding the types of variables such as whether they are qualitative or quantitative, it is vital for applying appropriate MCDM methods. We have different types of MCDM methods. Which MCDM method is more applicable for which kind of data, whether it is a qualitative data or quantitative data, which influence the accuracy of the decisions. Accuracy of the decisions means suppose we are involving experts. Now, whether the consensus among the expert is achievable or not, that is questionable. That's why which kind of MCDM that we are going to choose, that is most important for this particular PPT or presentations. Next is the impact on decision quality. The quality of the decision heavily depends upon correctly identifying and analyzing the variables in MCDM. Accurate weighting and evaluations lead to higher decision precision and reliability. So again, there is something called reliability and validity in testing. Now, suppose for example, A is greater than B and B is greater than C. But at the end, if the results say A, by default, A should be greater than C. But by result, in the result, we can see that C is greater than A. Then we can say there is something is not correct in our evaluation process, or we can say if the experts are given opinion, then their consensus or the evaluations somewhere something is problem. So we have to check the reliability and validity for each and every MCDM methods. So that is one of the point. So next is the we have to see the different types of data or the variables. Firstly, we have to check the qualitative variables. Now, what are the qualitative variables? These are basically of two types. One is the nominal scale or the ordinal scale. Nominal scale classify data into distinct categories into any quantitative value. Each category is unique and there is no ordering or ranking between them. For example, nominal scale. A nominal scale, I can say whether is a male or female. Male is a different category, female is a different category. We cannot rank them, we cannot put them in a order. We cannot say male is greater than female, female is greater than male. We cannot say that. These are the just nominal values. For example, I am Parthasarthi, another person will be there, Arjun. So Partha and Arjun are two people, so we cannot compare their with their name. So that's why these are known as the nominal values. Suppose something is there or something is not there, yes or no, then this type of variables are known as the nominal variables. Yes, binary things are always nominal things. Now another thing is like ordinal scale. If the data or the values of the data or variables are in ordinal scale, ordinal scales categorize data into a defined order, allowing a ranking of categories. However, the intervals between categories are not necessarily equal or null. For example, there are five students. Among the five students, somebody will get the first rank, second rank, third rank. So there is a order in that, first, second, and third. Now we cannot say first is second and third will sum up and we can say we'll get the first value. No, these are just from the numerical values. That order may be anything. Maybe we can say in planning we are like different street levels. So those are in orders, but we cannot say local streets are less important than the highways. They have their own charm, they have their own purpose, but there is a hierarchy. In that hierarchy, we can say there is a order of preference. People will travel more in the highway, but again, street or the local streets or the local roads, state highway, national highway, then expressways are there. So there is a order, but we cannot sum up or we cannot necessarily equal. That is one of the type of scaling systems for the attributes. Now the applications in multivariate decision making analysis, evaluating the subjective criteria. In MCDM, subjective criteria such as user satisfactions. For example, uh, we have gone for a dining. They are asking for feedback in a five rating scale. Five is extremely satisfactory, and one is extremely not satisfactory. That kind of data we can also evaluate in MCDM using the qualitative variables for more nuisance insights. So to getting into the details, we can have that kind of survey questionnaires and we can have that kind of variables data and we can do it. For example, case studies. Case studies in applied research often utilize qualitative variables to explore complex phenomena leading to rich detailed findings that inform decision making process. So most of the case study kind of research, we have this kind of qualitative data. For qualitative data, it is very difficult to quantify them. So MCDM simplify those qualitative data into quantitative, and it is very easy for us to do such kind of research, case study research. Next is like what are the major advantages and disadvantages. Qualitative data provides depth and detailed perspectives capturing the complexity of human experiences and offering insights that quantitative data might overlook. So most of the time, so in qualitative data, we are getting the quality rather than it's just a number. So quality always matter. Whenever we can say the definition of PhD, PhD is always like philosophy. Philosophy is always qualitative. Whether we are doing relating with the quantitative data or qualitative data, so at the end, whatever results we are getting, we have to infer it in terms of quality. So that's why qualitative data research is always important, and that kind of research we can do it MCDM process. Now there are some kind of potential limitations, like despite their richness, qualitative data can subjective and harder to generalize. It is very difficult to generalize. Generally, qualitative data, we are dealing with case study on specific ground, geographical location, on a particular cases, and their analysis can be time consuming and complex. So mainly in MCDM process, if we are dealing with the qualitative data, the time consuming process is too lengthy and it is very much complex. Now the quantitative variables. Again, the definition of characteristics of quantitative variables, we have two type of scaling process. One is the interval scale and ratio scale. All these four kind of scaling systems for variable data collections, like nominal, uh, then ordinal, then interval and ratio. These are the four different types, whereas two are qualitative and two are quantitative. So in interval scales are numerical scales where interval between values are interpretable. So we can give a particular distance, like these are the different values, or we can sum it, we can minus it, but there will not be any true zero. For example, temperature, we can say temperature is going to rise, temperature is going to reduce, but we cannot say temperature 5 plus 5 degree temperature is 10 degree temperature. So that is one kind of a interval process, whereas ratio scales have both true 0 point and equal intervals, allowing for comparison of absolute magnitudes and meaningful ratios. So these are the normal continuous data most of the researchers are doing with the ratio scale data, whereas some of the qualitative data and interval data. So at the crux or at the inference, I can say for all four types of scaling systems in the data variables, we have all kind of systems. We have different types of MCDM process for which we can do our decision making process. Next is application in MCDM, measuring objective criteria. Quantitative variables helps in measure objective criteria precisely, providing a consistent basis for decision making in multi-criteria decision making analysis. Whereas statistical analysis, they enable detailed statistical analysis to identify patterns and relationships, making it easier to derive meaningful insights and conclusions. So in both the cases, measuring uh, both the qualitative and quantitative, as well as we can use the statistical inferences for that. Now the advantages and disadvantages of quantitative data. Quantitative variables are oftenly high precision and consistency in data measurement, enhancing the reliability of the findings derived from them. So generally they are morely precision data. We don't have to worry about the errors. We don't have to worry about their consistency. Whereas there are some kind of demerits or disadvantages, we can say. They are complex interpretations. Interpreting data from quantitative variables can be complex, requiring a strong understanding of statistical method and potential sources of error. So mostly whenever we are getting data quantitatively, there is always like what kind of data, like there are some kind of parametric tests are there, non-parametric tests are there, which kind of test we are going to conduct, whether they are homogeneous, they are heterogeneous. There are so many complexities are there. In the further videos we are going to discuss all these things. So again we have mixed variables. Mixed variables, here we have both combination of qualitative and quantitative data as well as real world examples. So combining qualitative and quantitative data in MCDM, we can do both the things. Okay, involves both numerical data and non-numerical insights to create a holistic view of the resource problem, enriching the analysis problem. So majorly whenever we are doing the parametric test like t-test, u-test, z-test, z-score test, so there we need a particular type of variable. We cannot compare one versus another, one scale versus the another scale variables, but in MCDM that can be possible. So I can say all four kind of scaling systems for the variables here in MCDM, we can do it in a proper way, in a sequential way, in a robust way, and the uh, with the help of experts also, without the help of experts also. So that can be possible if you are taking a example. In practice, mixed variables can be seen in fields such as market research, where consumer feedbacks in the scale of satisfaction level 1 to 5, 1 to 7, 1 to 9 scales are there, whereas along with the some kind of quantitative variables like sales data, which are quantitative to understand the product performance. So here we have to seek the data like uh, clients feedback in terms of quality and product sales in terms of monetary. Then we can say and we can infer that what will be the product performance. So next is like analytical methods. Now integrating scoring systems. Mixed method research. Integrating scoring systems are used combining both qualitative and quantitative data to create a singular score or index, facilitating easier interpretation and comparison of complex. So here we can say both the qualitative and quantitative, we have to make them in a common score, that is known as the normalization method. Next is the mixed method research. Mixed method research employs both qualitative and quantitative techniques to collect and analyze data, helping to leverage the strength of both approaches for robust and comprehensive findings and evaluations mechanism. Next is like for mixed method approach, what are the advantages and disadvantages? We have a comprehensive decision making process, whereas the complexity of data handling for all type of variable scaling systems, it is a little bit confusing and complicated. So again, to ensuring the accurate analysis and interpretations, it will be a little bit difficult, but I cannot say it is much difficult, but a little bit difficulty level we can face. Again, we'll see in the upcoming videos what are the difficulties, or when we'll dealing with the my aim is to do 5 alternatives and 5 parameters with beneficial and non-beneficial analysis. We'll try to do many more videos for this. Next is like handling and processing variables. How to handle and how to process the variables. Data normalizations, techniques and importance. Data normalizations is transforming variables to a common scale, as I discussed you. Suppose one of the variables unit is in terms of money. Some of the units variable is in terms of horsepower. Some of the variables unit is in terms of kilometer per hour. So how to make them in a common ground, so that either we can make all the units in a same scale, or we can make it unitless. That's why data normalization is always required for the redundancy and improve algorithm processes. For example, in MCDM, normalization makes diverse criteria comparables. Example includes minimum maximum scaling or z-score normalizations methods. Standardization methods are there. We can see through the examples in the near future. Next is like weighing assigns, subjective weighing assigned and objective weighing assigns. As I discussed earlier also, subjective weighting relies on expert judgment or stakeholder inputs. Techniques like Delphi method, pairwise comparison methods, AHP methods, all these are like from the help from the experts. We can do subjective weighting methods that the output will be in the numerical form in terms of percentage, whereas some of the objective weighing methods are also there from the data, or from the data characteristics very we can generate the weights. From that, weights are nothing but the level of importance between the two parameters or multiple parameters. Which parameter is more important than the other parameters, that we have to check through the weighing methods. So some of the common methods are like data envelopment analysis, DEA, and there is another method is called critic method. There is something called GRA method. Uh, there are so many methods. There is something called PSI, preference selection index method is there for weight assignments. So let's see. in the near future, what we can do. Then at the end, we have to do a sensitive analysis. The purpose and methods for doing sensitive analysis is how variations in input affects outcomes. If there are 5 parameters, what will be the outcome? If there is 4 parameters, we can remove one parameter and we can say what will be the result. If the results are coming same, then we can remove one of the parameter and we can say, suppose there are 3 parameters a, b, c. If a and b, a is greater than b, b is greater than c in our model, then we can say all the parameters are good enough. But if we are removing a in our evaluation systems, then b and c, if b is greater than c, then we can say our model is robust or we have a sensitive analysis. Similarly, for the alternatives also, we can remove one of the alternatives for evaluations. If the hierarchy of A1, A2, A3 are same, then we don't have any problem. Then evaluating robustness involves assessing the stability and reliability of the decision making model under varying conditions and assumptions. Suppose one of the condition is like I am from Odisha, India. So if my evaluation system is in Odisha is established, can we make the same evaluation models for Karnataka or Maharashtra or Tamil Nadu or Punjab? If that is, if the evaluation model is applicable, then we can say evaluation's robustness we can achieve. Now let's discuss some of the practical applications. Case study: environmental decision makings. One of the problem definitions for environmental studies, I can say, identify specific environmental challenges to address, such as pollutions, resource management, or conservations, to frame the context of the decision making. Variable selections: choose relevant variables such as air quality, water level, biodiversity indicators necessary for effectively environmental analysis and solutions. What can be the analysis or results we can get it from the through the MCDM process? Evaluating the collected data and presenting finding to illustrate the outcomes and effectively of the different decision making approach in environmental management. Another case study will be our healthcare decision makings. What kind of problems that we'll get for healthcare, like outline specific healthcare issues such as patient treatment plans or resource allocations, which require structured decision making framework. Like what will be the variables for patient age, medical history, treatment options are the variable options. Now what kind of analysis or result we can get? Presenting data analysis, the results showcasing how evidence-based decision making can lead to better patient care and resource management in healthcare. Another example is heritage management decision making. Uh, how we can get the problem identifications, defining challenges in heritage management such as preservations, funding, public engagement, stakeholder analysis, to establish the context for decision making. Variable selections: what are the variables? Selecting important variables including cultural significance, tourist impact, financial resources, architectural, historical, environmental. All these will be the variables which are directly or indirectly affecting the heritage. Now, what kind of the analysis or outcome that we are expecting? Analyzing data on heritage sites and presenting outcomes to demonstrate the effectiveness of decision making strategy in preserving cultural heritage. Along that, I can say we have different types of strategies like adaptive reuse. What will be the present use? What will be the future use? From the previous use, what will be the profitable business for or economic development? What will be the uh, optimum use that we can do for a heritage? So all these are cases. We'll discuss all these cases in detail one by one with the different types of MCDMs. So again, thank you. Again, I am Dr. Parthasarthi Mishra, Associate from Faculty of Architecture. If you have not yet subscribed to my channel, please subscribe it. We'll discuss. Please, if you have any issues, please give comment. I'll try to resolve it. If you have If you want to improve my presentation skills, please also comment so that I will try to improve it from my own sides. And thank you for now. Again, we'll have another topic in a good topic in the next video. Thank you.